Continuing with section 1.2, let's look at the next example. So we are given a function and we have to figure out if this is a solution for the given differential equation, which is over here. So as usual, we will start with our given function, which is y is equal to x to the m, and we need to find its derivative because that's what we need to plug in. So the y prime will be equal to m times x to the m minus 1. We apply the power rule. And now for the double prime, y double prime, or the second derivative of y, what do? We differentiate the first derivative. So now I will be finding y double prime, which is means again I apply the power rule to y prime. So I get m times m minus 1 to the x to the, now we subtract 1 from m minus 1, so we get m minus 2. Now we plug in the equation, so we get 3x squared times, so I'm going to keep this in parentheses, m times m minus 1 times x to the m minus 2 plus 11x, and now the y prime. So y prime is m into x to the m minus 1 minus 3y. So y is just x to the m, and this whole thing equal to 0. Now you should notice when we try to simplify this quantity, so note here there is an x square here, and there is x to the m minus 2. So we combine the powers because they are being multiplied, so this will become 3x to the m, and then inside I have left m times m minus 1, so let's just distribute it. So we get m squared minus m plus this stays as it is, 11x, but now notice here this also becomes x to the m because we have an x here and then we have a x to the m minus 1 in here. So when we multiply, the powers get added and we get m minus 1 plus 1, so we end up getting x to the m. So we have now 11m x to the m, and the last one is just 3x to the m is equal to 0. So now x to the m can be factored out, and I will also now distribute this 3 over this. So I factor out the x to the m, and I'm left with 3m squared minus 3m plus 11m minus 3. So now according to our algebra, we say either x to the m is 0 or 3m squared plus 8m minus 3 is 0. So now, well, when x to the m is 0, this means x is 0. So this is the trivial solution. So we don't worry about that. Now we look at this second factor, which is a polynomial, quadratic polynomial, and it can be easily factored. So we factor it. And we set each factor 0. So this gives me m is equal to 1/3, and this gives me m is equal to minus 3. So the values for m for which x to the m is a solution are when m is equal to 1/3 or when m is equal to -3. Going to the next example, it says you consider this linear equation and verify that the function c of x equal to c1 e to the x plus c2 e to the minus 2x is a solution to the linear equation. So we, as usual, let's say this is y is equal to c1 e to the x plus c2 e to the minus 2x. So I'd find the first derivative, y prime, which is equal to c1 e to the x minus, well, it's going to be plus c2 e to the minus 2x times minus 2. So I'm going to put the minus 2 in the front. So I get minus 2 c2 e to the minus 2x. Then we find the second derivative, which is going to give us y double prime is equal to c1 e to the x. Okay, so now we had already a minus 2 and another minus 2 is going to come down, so we get plus 4 c2 e to the minus 2x. We just now have to plug it in and check if the equation comes out true. It should come out true because we are verifying. So it means it's already understood that it is a function. Okay, so how do we do that? So the second derivative, plug in. So we are getting c1 e to the x plus 4c2 e to the minus 2x. So this is the second derivative. Then according to the equation, we have to plus dy by dx. So plus c1 e to the x minus 2c2 e to the minus 2x. Okay. So this is the second derivative. First derivative. So this is y double prime, this is y prime, and now the last term I have to write here, which is minus 2y. So minus, so this is y, so I'm going to distribute the negative 2, so I end up getting minus 2 c1 e to the x minus 2 c2 e to the minus 2x, and the right hand side is 0. So now let's check on the left hand side, what do we get? So note here, so this is c1x, this is c1x e to the x, same term, so it becomes 2 c1 e to the x, but then we have a negative 2 c1 e to the x there, so they cancel out, makes it 0. In the same way, we have a 4 c2 e to the minus 2x, this term. And then we have a negative 2 c2 e to the minus 2x and another negative 2. So one is this term and then the last one, this one. So they all combine and they make it a 0. So we are getting 0 is equal to 0. So yes, we have verified. Okay, so now we have to check, we have to find out the C1 and C2 for the different conditions or different initial conditions. So how do we do that? Now remember what we have is that we have the y equals C1 e to the x. So we know that this is a solution. And now we have to find the initial condition. So you can see one initial condition is on y, this one, and the other one is on y prime. So it means we need the y prime as well. So let me write it here, y prime c1 e to the x minus 2 c2 e to the x, e to negative x, sorry. Okay, so now we plug in first condition, which is saying y of 0 is equal to 2. So you should understand what it means. It means when in the function y, or in the equation which is for y, when you plug x to be 0, okay, when x is 0, y is going to be 2. So this is how I plug in. So I say, okay, c times e to the 0 plus c2 e times e to the minus 2 times 0, which is 0. This will be equal to 2. So simplifying, because e to the 0 is 1, we have the equation c1 plus c2 equals 2. So this is one of the equations, and then we will find another equation. So we will give it a number, call it question number 1. Now we will use the other condition, which is on y prime. So what is the condition? It says y prime of 0 equals 1. So again, doing the same thing, that when I plug in 0 for x in y prime, the value of the y prime is 1. So I get c1 e to the 0 minus 2 c2 e to the 0 equals 1, or c1 minus 2c2 equals 1. So this is the second equation. Now we have to solve basically the first and the second equation. So you can do it by elimination or by substitution. So let's do it by elimination. So let me put the second equation down under here, so that it's more clear what is happening. Okay. So if you notice, if we just subtract equation 2 from equation 1, so 1 minus 2 gives us, so c1 minus c1 cancels out, so we get c2 plus 2c2, so we get 3c2, and on the right hand side we end up getting 1, which gives us that c2 is equal to 1 over 3. So this is one of the values. What about the second, the value of c1 now? We can use any equation, any of the equation 1 or 2. So because equation 1 is a little bit simpler. So from equation 1, c2 is equal to 2 minus c1. So sorry, c1 is, we have to find c1 now, because we already found the c2. So now we have to find c1. So c1 equals 2 minus c2. So c1 will be equal to 2 minus 1 over 3, which is going to give you 5 over 3. Therefore, c1 is equal to 5 over 3 and c2 is equal to 1 over 3. So this is our answer. Now looking at the next part, second part. So again, remember our equations are the same, just only the initial conditions are different. So now when I use this initial condition, my equation will become c1, so now this time e to the 1, which we just can just write e, then plus c2 e to the negative 2, and this is equal to 1 this time. Okay, so this is our first equation. Second equation we'll get from here. So this will give us, so I number this one as 1. So I get c1 e minus 2 c2 e to the negative 2 is equal to 0. Okay. So we'll call this number 2. So we'll do the same kind of trick that we did before, subtract the two equations. So when I subtract equation 2 from equation 1, so I write 1 minus 2. Or you can write in words subtracting equation 2 from equation 1. So 1 minus 2, this gives me, so first terms cancel out, second terms get added, and I end up getting, so these two get added, and I end up getting 3 C2 e to the minus 2 is equal to 1. So we move things over. So note here, so this is something you can do like in different ways. So e to the negative 2 is, remember, 1 over e square. So you can first write it like this, 3c2 over e square equals 1, or we can do it, we can first move things on the right and then do this. But anyhow, in either way, so this will give us c2 equals e over 3, 1 times e square over 3, or 1/3 e square, so whichever way you prefer. So this is our C2, and then how do I find C1? Again, I can use the first or the second equation. So I think second one is easy because that is there is no addition or subtraction involved. So from two, what do we get? We get C1 E equals 2 times C2 times e to the negative 2. But again, e to the negative 2 can be written as 1 over e square. So C1 E equals 2 into, or 2 over e square, you can say, times C2. But C2, now I can replace it. What was C2? C2 was equal to 1 over 3 e squared. So I can write 1 over 3 e squared. But then e squared and e squared cancel out. So this gives me 2 over 3. So now I have C1e is equal to 2 over 3. So C1 will be equal to 2 over 3 into 1 over e. So you can think of it as 2 over 3e, or you can think of it as 2 over 3 e to the negative 1. So he says C1 is equal to 2 over 3 e to the minus 1, and C2 is equal to 1 over 3 e square. Okay, I'll stop here now and do the next example in a separate video. Thank you.